Hi guys, welcome back. We're going to start up with 14 here. This time I don't have anything in a denominator to worry about, so we can plug this guy straight in. Woo! So this would be e cubed times cosine of pi times x, which is 3 over 3. Well, my 3's are going to cancel. So this is e cubed cosine pi. Where is pi on my unit circle? That's 180 degrees. That's the point -1, 0. Cosine is your x value, so this would be e cubed times -1, or negative e cubed. All right, 15. I can't plug 1 into here. There's nothing really to factor here, but I see that square root, which screams what to you? Hopefully by now you're saying conjugate. So what I can do is multiply this by the conjugate, which would be square root of x plus 3 plus 2, square root of x plus 3 plus 2. That's going to give me the limit as x approaches 1. Square root of 3, or square root of x plus 3 times square root of x plus 3 would be x plus 3. We lose the square root. And then I've got 2 times square root of x plus 3, negative 2 times square root of x plus 3. They cancel each other out. That's why we use the conjugate. Negative 2 times 2 would be -4. On the bottom, before you get too excited and start multiplying this binomial, keep that x minus 1 by itself, because that's what we're trying to get rid of. And with any luck in the numerator, we'll get x minus 1. And notice in the numerator, you got x plus 3 minus 4. Well, guess what that is? 3 minus 4 would be -1. So you got x minus 1 in the numerator. Now you have it in the denominator. And they cancel, which means I've got the limit as x approaches 1 of 1 over the square root of x plus 3 plus 2. That's 1 over the square root of 1 plus 3 plus 2. 1 plus 3 is 4. Square root of 4 is 2 plus 2 would be 4. All right, at 16, what do we have happening there? Well, if I plug in 3, I've got 0 in the denominator. Can I cancel it out of the numerator? No, it doesn't cancel out. So we no longer have a hole there, which means we can no longer find a limit there. Instead, what we have is an asymptote. It doesn't cancel, it's an asymptote, which means we're either going to positive or negative infinity on either side, but I can't have an overall limit. They're saying that's fine, just find the right-handed limit for us. So this is the one where we find a table. Here's my x, my y is going to be x plus 3, x minus 3. I'm going to come up with some number that's slightly bigger than 3 because we're looking for a right-handed limit. So slightly bigger than 3 would be 3.1. And all I'm worried about is it positive or negative? So this would be 3.1 plus 3, 3.1 minus 3. Positive plus a positive is going to stay positive. 3.1 minus 3 is going to be positive. Positive divided by positive is still positive. So this is going to positive infinity. Number 7. Again, we could try to factor this guy, but it will not factor. I don't think. Well, let's see. Either way, they're looking for a right-handed limit here. So my gut is to just do a table, but let's see what happens. I'm curious now. So we got 2x, x, and these would have to be 3 and 3 or 9 and 1. I don't think 9 and 1 is going to work. But I could have a minus 3 and a minus. That works, right? Negative times negative is positive 9. And then negative 3x, negative 6x is negative 9x. The bottom I've got x minus 3. X plus 3. Oh, look, this guy cancels. Looks good, right? Well, what happens when you put in negative 3? Wah, wah, right? This is your hole for the rational function, but x plus 3 is your asymptote. So that's why they're asking for a right-handed limit. But this helps us. So instead of plugging a number into this big thing, we actually want to plug it into the reduced fraction. So 2x minus 3 over x plus 3. That's what we're going to test. So what's a number slightly bigger than negative 3? And I have to think about this one for a second. Slightly bigger than negative 3 would be negative 2.9. So I've got 2 times 2.9 minus 3 over 2 times negative 2.9 minus 3 and negative 2.9 plus 3. So here I've got negative times positive, so this would be negative minus something that's going to stay negative. And then negative 2.9 plus 3 would be positive. Negative divided by positive would be negative. So our overall limit here is going to be negative infinity. All right, 18 is another one where we're going to try to find a common denominator and hope something works to where we can get rid of this x. So the limit is x goes to 0. Have x on the bottom. What's my common denominator between those two guys? They have nothing in common, so I'm going to multiply them together. This guy needs to be multiplied by 2 to get to the common. The other one needs to be multiplied by x minus 2 to get to the common. The 2's will cancel, which means I've got the limit as x approaches 0 of x over 2 times x minus 2. I'm going to go ahead and flip that bottom fraction multiplied by a reciprocal. We multiply by the reciprocal, that allows us to cancel out the x. And that gives me the limit as x approaches 0 of 1 over 2 times x minus 2. Now I can finally plug in that 0. So 2 times 0 minus 2, it's going to be minus 1/4. There's one more, so let's go ahead and eke it out. Here is another piecewise graph, or piecewise equation function. Remember, to find the limit of it, we need to find the left-hand limit. So the limit as x goes to negative 2 from the left-hand side. Limit as x goes to negative 2 from the right-hand side. I don't really like this one because it doesn't give you like an f of x to call it, but we can plug in 2 minus x. That would be part of this function that we're going to do for the left-hand limit, because that's where it's less than negative 2. When it's greater than negative 2, we're going to plug it into x squared minus 2x. So here I've got 2 minus a minus 2, 2 plus 2, which is 4. The bottom one, I've got negative 2 squared minus 2 times negative 2. Negative 2 squared is 4. Negative 2 times negative 2 is 4. 4 times 4 would be 8. Again, these guys are not equal to each other, so this limit does not exist. All right, and that is it for 8.19.19 classwork. I will hopefully, I will have to make it work. Get you your last classwork notes done tomorrow. Have a good night, guys.